welcome back to my channel. Today we're going to be looking at the multiple choice section of the higher specimen paper, which can be found on the SQA website. If you haven't already tried this paper, go on the SQA website and try it now and use this video to help you mark it. Question 1. Which of the following elements at room temperature could be described as monatomic? As part of the higher course, you're expected to know the bonding and structure of the first 20 elements. The different bondings that there are metallic, covalent network, covalent molecular, which includes small molecules such as phosphorus and sulfur, as well as diatomic molecules, and then monatomic. The monatomic section is the noble gases. This means that A, argon, is our answer, as it is one of the noble gases. Boron has a covalent network structure. Iodine is a diatomic molecule, and sulfur exists as rings of S8. Question 2. The table shows the first three ionization energies of aluminium. Using this information, what is the enthalpy change in kilojoules per mole for the following reaction? So the values shown in here in the table is the energy required to remove 1 mole of electrons from a mole of aluminium atoms in the gaseous state. The second ionization energy is the energy required to remove 1 mole of electrons from 1 mole of aluminium plus ions, and the third ionization energy is the energy required to remove 1 mole of electrons from aluminium 2 plus ions. All of these values are positive for removing electrons. When we put electrons back in, as we have in this equation here, this will release energy, so we can immediately eliminate answers A and C as they are positive. Here we have aluminium 3 plus. We're putting back in the last 2 electrons which were removed. So the energy will be the third and the second ionization energy added together, and then it will be getting released, so it will be negative. This means that our answer will be D. Question 3. Which element has the greatest attraction for bonding electrons? This question is really hoping that you know the definition for one of the terms which you need to know from the periodic table. That is electronegativity. The definition of electronegativity is the attraction for a bonding pair of electrons. You can find this on page 11 of the data book. If you look up page 11 of the data book, you can find that the electronegativity for bromine is 2.8, for chlorine is 3.0, for lithium is 1.0, and for sodium is 0.9. This means that our answer is B, chlorine, as it has the highest electronegativity. Question 4. Which of the following chlorides is likely to have the most ionic character? Here, we're looking for the largest difference in electronegativity. So the difference in electronegativity between beryllium and chlorine, so beryllium is 1.5 and chlorine is 3.0. So we have a difference of 1.5. Calcium is 1.0, chlorine is 3, so that's a difference of 2. Cesium is 0.8, chlorine is 3, so that's a difference of 2.2. And lithium is 1.0, chlorine is 3, so that's a difference of 2. The largest difference is therefore between cesium and chlorine. Cesium has the lowest electronegativity on the periodic table. Question 5. Which of the following elements would have the strongest London dispersion forces? London dispersion forces rely on electron clouds, So what we're looking for here is which of these elements has the most number of electrons and therefore the largest electron cloud. Argon exists as monatomic gas, so is single argon atoms, and has 18 electrons. Chlorine is diatomic and exists as Cl2. Each Cl has 17 electrons, therefore in total we have 34. Nitrogen exists as N2. Each nitrogen has 7 electrons, so in total we have 14. And then lastly, oxygen exists as O2. Each oxygen has 8 electrons, so we have 16 in total. This means that chlorine has the largest electron cloud and therefore the strongest London dispersion forces. Question 6. The shapes of some common molecules are shown below, and each contains at least one polar bond. Which molecule is non-polar? So here we're looking for dipoles in the molecules. So hydrogen is less electronegative than chlorine, so there will be a dipole in this direction. Oxygen is more electronegative than hydrogen, so there is a dipole in this direction. For carbon dioxide, the electrons are being pulled out towards both of the oxygens, and it is symmetrical, therefore there is no dipole. And in trichloromethane, the chlorines at the bottom are more electronegative than the hydrogen at the top, so we have a dipole in this direction. This means that C, carbon dioxide, which is symmetrical, is our non-polar molecule. Question 7. Which of the following is an isomer of hexantool? Let's first of all draw out hexantool. So hexantool has a formula of C6H14O. So if we look at the first molecule that we have here, if we were to name this, we would number from the end closest to the hydroxyl, and we would find that this is hexantool, so that cannot be our answer. For B, we have a formula of C6H12O, so we don't have enough hydrogens. For C, if we number from the end closest to the hydroxyl group, we find that again this is hexantool, so the answer is D. Question 8. Aspirin and oil of wintergreen are used in medicines. Their structures are shown below. Identify the term which can be applied to aspirin but not to oil of wintergreen. So all of these terms are functional groups. So if we have a look at the molecules, we can see that in aspirin we have an ester link, and we have a carboxylic acid. In oil of wintergreen, we have a hydroxyl group and an ester link. Therefore, the term which applies to aspirin but not to oil of wintergreen is the carboxylic acid. Question 9. The structure of caraphyllene, which can be extracted from clove oil, is shown below. Which of the following would be the best solvent for extracting caraphyllene? So this molecule has only carbons and hydrogens. We have no hydroxyl or amine functional groups. Therefore, this is going to be highly soluble in something which is only has carbons and hydrogens present. Therefore, this would be most soluble in A. Question 10. In alpha amino acids, the amino group is on the carbon next to the carboxyl group. Which of the following is an alpha amino acid? So here we just need to look at the structure to be able to find the carboxyl group and the amine. So here we have the carboxyl group and here we have the amino group, and we can see that this is 2 carbons away, so this is not an alpha amino acid. Here we have the carboxyl group and the amino group, and they are on this carbon here. So this one would be our alpha amino acid. If we look at the other two, we can see that the amino and the carboxyl group are further apart. Question 11. The 2-pyrones are esters used in flavourings and in perfumes. The name 2-pyrone comes from the carbonyl group being in position 2 in the structure shown. Which of the following structures is the pyrone responsible for the smell of chocolate? 4-hydroxy 6-methyl-2-pyrone. So what we're looking for here is, if we count round from the oxygen being number 1, we are looking for a hydroxy on carbon 4 in this position and a methyl in carbon 6 this position. So we have 2 possible answers with the hydroxy in position 4. So C and D can be eliminated. And now we're looking for our methyl group to be in the 6th position, which is here. So B is the answer. Which of the following reactions can be classified as a reduction? So in A, we have an alcohol, and this is going to a carboxylic acid. So that is an oxidation. In B, we have an alcohol, and that is going to a ketone. So that is also oxidation. In C, we have a ketone becoming an alcohol. So this one would be reduction. If we check D, we have an aldehyde, and that is going to a carboxylic acid, which is oxidation. So C is the reduction. Question 13. Which of the following structural formulae represents a tertiary alcohol? So in a tertiary alcohol, we have a carbon with the hydroxyl group, and that carbon has 3 carbon chains or R groups attached to it. So here we have a hydroxyl, but it's on the end of a chain, so this one would be primary. Here we have our hydroxyl, and we have 3 carbon chains, so this one would be tertiary. Here we have hydroxyls, and the carbon is attached to 2, so this would be secondary. And then again, this one would be secondary. So B is the tertiary alcohol. Question 14. A mixture of sodium bromide and sodium sulfate is known to contain 10 moles of sodium and 4 moles of bromide ions. How many moles of sulfate ions are present? So first of all, if we start with the formula for sodium bromide and sodium sulfate. When we have if we have a mixture of ions, for every sodium bromide, we get 1 sodium ion and 1 bromide ion. And for every sodium sulfate, we get 2 sodium ions and 1 sulfate ion. We have 4 moles of bromide ions, then we know that we must also have 4 moles of sodium ions from sodium bromide. In total, we have 10 moles of sodium ions. So if we do 10 minus 4, then we have 6 moles of sodium ions coming from the sodium sulfate. Since we have a 2-to-1 ratio, if we divide the 6 by 2, then we'll have 3 moles of sulfate ions present. Question 15. 4.6 grams of sodium is added to 4.8 litres of oxygen to form sodium oxide. When the reaction is complete, which of the statements will be true? And you're given the molar volume of oxygen to be 24 litres per mole. So if we start from the equation for the reaction, so we know that we have 4.6 grams of sodium and we have 4.8 litres of oxygen. So we need to first work out what our limiting reagent is. So if we find the moles of sodium, we do 4.6 divided by the gram formula mass, which is 23, then we have 0.2 moles of sodium present. For our moles of oxygen, if we take the litres and we divide by the molar volume, then we also have 0.2 moles of oxygen present. If we have 4 moles of sodium, we require 1 mole of oxygen. We actually have 0.2 moles of sodium, so we require 0.05 moles of oxygen. This means that oxygen must be in excess here. At the end of the reaction, we will have the excess oxygen left over as 0.15 moles of oxygen. If we look through the answers, we have A, 0.1 mole of oxygen will be left unreacted. That's incorrect. B, 0.1 mole of sodium will be left unreacted. All of the sodium reacts, so that is incorrect. C, 0.15 moles of oxygen will be left unreacted. And D, 0.2 moles of sodium oxide will be formed. So C is the answer. Question 16. A student obtained a certain volume of carbon dioxide by the reaction of 20 centimetres cubed of 2 mole per litre hydrochloric acid with excess sodium carbonate. The student carried out a similar experiment using sulfuric acid. Which solution of sulfuric acid would give the same final volume of carbon dioxide when added to excess sodium carbonate? So for the first reaction, we need to work out how many moles of hydrochloric acid were used. So we used 0.04 and we have a 2-to-1 ratio between the hydrochloric acid and the carbon dioxide, meaning that we would get 0.02 moles of CO2 produced. If we look now at the next reaction, we have a 1-to-1 molar ratio between carbon dioxide and sulfuric acid. So whichever of the answers we choose needs to be 0.02 moles of sulfuric acid. So for each of these, you're going to do concentration times volume. So here we have 2 times 0.01, which is 0.02, 2 times 0.02, which is 0.04, 4 times 0.01, and 4 times 0.02. This means that A is our answer and would produce the same volume of carbon dioxide. Question 17. In a reversible reaction, equilibrium is reached when? This is purely a definition question that you need to know. So within an equilibrium reaction, the reactants are turning into the products and the products are turning into the reactants, and this is a dynamic process which does not stop. So A is not the answer. The concentrations of the reactants and the products are rarely equal but are always constant. So B is not the answer, but C is. Question 18. Ethanol is manufactured by reacting ethene with steam. Which set of conditions would give the best yield of ethanol at equilibrium? So here we're looking for temperature and pressure. So the enthalpy is what we will look at for temperature, and the number of moles of gas is what we'll look at for pressure. So a negative delta H value means this is an exothermic reaction. So this means that we give out heat. If heat is given out in a reaction, then to shift this to the right, then we need to lower the temperature. If we now look at the gas, we have 2 moles of gas going to 1 mole of gas. To shift this to the right, we need to increase the pressure so that it is shifted to the side with less moles of gas. Therefore, we would use low temperature, high pressure. Question 19. When copper carbonate is reacted with excess acid, carbon dioxide is produced. The curves shown were under different conditions. So we're trying to go from curve P to curve Q. So what we'll do is we'll add in a curve for each of the different answers here. So if you were to increase the concentration of the acid, then the final volume of carbon dioxide would be the same. However, you would get there quicker. If you were to decrease the mass of copper carbonate is where the carbon dioxide is coming from, so you would end up with a curve where you would finish lower. If you were to decrease the particle size of the copper carbonate, it would go faster, but would end up at the same point. And if you were to add a catalyst, it would go faster, but you would end up with the same volume of gas. This means that B is our answer. Question 20. The potential energy diagram for a reaction is shown below. The delta H for the forward reaction is what? So delta H is the products minus the reactants. So here our products is negative 227 minus the reactants, which is 134. So the answer will be D, negative 361. Question 21. Which of the following is not a correct statement about the effect of a catalyst? A catalyst provides energy so that more molecules have successful collisions. Catalysts don't provide energy, they lower the energy that molecules need. This gives an alternative route to the products and allows more molecules to have energy greater than the activation energy. So the incorrect statement is A. Question 22. Which of the following equations represents an enthalpy of combustion? So the definition for an enthalpy of combustion is the energy released when 1 mole of a substance burns completely in oxygen. So all of these have 1 mole of a substance burning. They're all burning in oxygen. For complete combustion of any hydrocarbon or carbohydrate, we would get carbon dioxide and water being produced. So the only reaction which has carbon dioxide and water being produced is A. Question 23. The energy released when 2 moles of each reactant are mixed and ignited is what? So in the original reaction, we have a 5:4 ratio. When reacting 2 moles of each reactant, we need to find out which of these is in excess to be able to work out what to do with the values given. If we start with 2 moles of this reactant, to work out how many of the other reactant we need, we would do 2 divided by 5 times by 4 to get 1.6. This means that this one is in excess. To be able to work out the energy released when 2 moles of this reactant are ignited, we take the value given in the question, which is negative 5,116, divide it by 5 and times it by 2, which gives us our answer of 2046. So A is our answer. Question 24. A chemist analysed a mixture of 4 dyes, A, B, C and D, using gas-liquid chromatography. In this technique, compounds are separated depending on their polarity, with the most polar having the longest retention times. The chromatogram obtained is shown below. Which of the following compounds was present in greatest concentration? So on the chromatogram, this is the most polar compound, and the second most polar has the greatest concentration. So now we need to look at each of the molecules. So for A, we have 1, 2, 3, 4, 5, 6, 7 polar groups on A. We have 1 on B. We have 1, 2, 3 on C, and 1, 2, 3, 4 on D. This means that A is the most polar and therefore has the longest retention time. D is the second most polar. It is also the one with the greatest concentration. Finally, question 25. Ethanol and ethanoic acid are flammable liquids. Which of the following diagrams shows the correct setup for the separation of ethanol from ethanoic acid? If ethanol and ethanoic acid are both flammable, then you don't want to be using a Bunsen to separate them, so C and D can be eliminated. We're then looking at the distillation apparatus. For a distillation apparatus, the water should always go in at the bottom of the condenser and come out at the top, meaning that B is our answer. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and follow me on Twitter at MissAdamsChem for regular updates on new videos. Follow me on Instagram, Miss Adams Chemistry, for flashcards, and remember to ring the bell. Bye for now.